Now, in the mitochondrial matrix, the acyl-CoA molecules. What are the acyl-CoA molecules? Acyl-CoA molecules are the molecules that are formed when the fatty acid reacts with coenzyme A. So, if we had a, say, capric acid, right? So, CH3, CH2, 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 C double bond OH. If this acid reacted with coenzyme A, what we get is this part of the molecule changes to S coenzyme A, right? So acyl coenzyme A, these molecules undergo beta oxidation. Okay, so in the mitochondrial matrix, the acyl-CoA molecules undergo beta oxidation. Beta oxidation has 4 steps. Beta oxidation has 4 steps. So what's the first step? The first step is CH3 with the same capric acid, CH2, 6, CH2, CH2, C double bond O, S, CoA, right? So this is your alpha carbon, this is your beta carbon, right? So in the first step, which is the oxidation, FAD is used up and you form and FADH2 is formed. Remember, this is the oxidizing agent, so it will get reduced. The enzyme that is used here is acyl-CoA dehydrogenase. Acyl-CoA dehydrogenase. Right? So, the first step is oxidation, where the acyl-CoA molecule of the fatty acid is oxidized to trans-acyl-CoA. So you get CH3, CH2, 6, CH, double bond CH, C double bond O, S, CoA. So where is the change? Here, alpha and beta carbons, right? So this is oxidation, right? So dehydrogenase. Now, second step is the hydration. Hydration adds components of water to the trans double bond and forms a hydroxyl group. Okay, it adds water, so this is hydration. It adds water, so CH3, CH2, CH, OH, CH2, C double bond O, S, CoA. So there is addition of water in this case, right? So OH gets added here and H gets added here. So this is the second step, hydration. The third step to the previous molecule, NAD plus gets reduced and it oxidizes the molecule that was formed in the previous case, which was the beta hydroxyacyl, right? So because on the hydroxyl group a OH was added, so beta hydroxy acyl coenzyme A. To that gets oxidized to give you CH3, CH26, C double bond O, CH2, C double bond O, S, COA, coenzyme A, right? So here that means this is the change. See how this got oxidized, right? At this point, the fourth reaction is the cleavage reaction. This is the final step. The fatty acid is cleaved at the beta carbon to yield a 2-carbon acetyl-CoA, right? It is cleaved at the beta carbon. So you get at this point, right? So you get CH3, CH2, 4, CH2, CH2, C double bond O, S, COA, and you get a CH3, C double bond O, S, COA, which is the rest of the molecule, which is this part of the molecule. Okay, so this is the cleavage. Now, you don't have to know the mechanism, how this cleavage is happening, where are the molecules coming from and all that. There are a couple of important features that you need to know. In this process, in this whole 4 reaction that we have learned, the capric acid undergoes beta oxidation, okay, and in the beta oxidation we get NADH as one of the products, acetyl-CoA as one of the products, right? So what's the importance here? These 2 molecules are very important coenzymes in metabolism reactions in biochemistry. So, beta oxidation of fatty acids produces NADH and acetyl coenzyme A, which are important. So, this is just like glycolysis producing ATP. ATP is the energy carrying molecule, right? It gives energy to the body. Just like that, NADH and acetyl coenzyme A play an important role in lot of biochemical reactions, and beta oxidation of fatty acids gives these 2 molecules. So that's the importance of beta oxidation. Now, beta oxidation depends on the length of the fatty acid. So that tells you, the length of the fatty acid tells you how many times these 4 reaction cycle will be repeated. So this is a 4 reactions, one cycle of 4 reaction: oxidation, hydration, oxidation, cleavage, right? So we had a 10 carbon fatty acid, so CH3, CH3 6, CH2 6, and CH2, CH2, C double bond O, S, coenzyme A, right? So in the first cycle, you end up with 2 carbon acetyl coenzyme A. So you get a CH3, C double bond O, S, COA. What you're left out with is 8 carbons, right? CH3, CH2 4, CH2, CH2, C double bond O, S, COA. And then When this undergoes beta oxidation, it gives away 2 more carbons. So you're left out with 6 carbons total. Then this gives away 2 more carbons. You're left out with 4 carbons. So this reactions will continue, these cycles will continue till you end up with just acetyl coenzyme A. Right? So every fatty acid, based on the number of carbon atoms it has, it releases acetyl coenzyme A according to the number of carbon atoms. So again, acetyl coenzyme A and NADH are important players in metabolic pathway. So that's the use of the beta oxidation.